Hi Geometry, this video is doing a few of the problems that were different on the review from the review video that I had filmed before. Okay, so this first figure, number 5, instead of being a sphere, number 5 is a square pyramid. So I know it's a square pyramid because the base is 14 by 14. And this 25 that I see is not the height. This is a slant height. It's on the outside of my pyramid. So one of the issues I have is I actually need the perpendicular height from the top of my pyramid to that 14 by 14 base. I need this red H. And I need to be able to figure out how to find it. And I'm thinking that if I would attach it to my slant height of 25, I could make a right triangle inside the middle of my square pyramid. And when I think about it, I actually know this edge I just drew in there, that would be 7. If this distance, total distance all the way across is 14, then the distance to the middle of this square base would be 7 feet. So I do have a right triangle here with a hypotenuse of 25, and one leg is 7 and the other leg is the height. So let's utilize our Pythagorean theorem. Remember that our hypotenuse has to be c. That's going to be my 25 squared. The other side is this 7 squared plus h squared in either order. So I'm getting 49 plus h squared equals 625. Let's subtract that over. I get h squared equals 576. I take the square root. Looks like my height of this is 24. So my height is 24. I can now find the volume of this. If I use my volume sheet, this is a pyramid, so I know it's 1/3 times the area of the base times the height. And so I know it's 1/3. The area of my base is length times width, side times side. So that's my 14 times 14. And the height of this pyramid from the base to the apex, the tippy top there, is 24. So I'm going to do 14 times 24 divided by 3. And it looks like we get 1,568 feet cubed. So I think the next problem that's different is on the back side. Hi Geometry, let's take a look at 11b next. A right cone has a base with a diameter of 12. So give me a moment. This is my circular base. This is my cone shape. I know it's standing straight up and down because it's a right cone. And if the base has a diameter of 12, that means it has a radius of 6. The volume of this cone is 48 pi cubic centimeters. And then it says, what does it say here? It says, what is the length of the segment drawn from the apex to the edge of the circular base? So a couple things. It's looking for this segment drawn from the apex to the edge of the circular base. It looks like I'm solving for slant height, which is often given the variable L. But I'm given volume, which I don't calculate with L. I calculate with H, the height. So it seems to me that I'm missing both the height and I'm missing the slant height. Well, I could find the height using volume because I'm just thinking out loud here. I know volume of a cone is 1/3 pi r squared h. So if I know my volume is 48 pi and I know my radius is 6, I could use my volume to find that h. Once I have h, I could use that h and that 6 to find my L. So it looks like this is going to be a 2-step process. Step 1 is to find my height, and step 2 will be to find the slant height. So when I'm solving this, the very first thing I have to think about is 6 squared is really 36. Don't cancel anything. Make sure you make that a 36. So I have 48 pi equals 1/3 pi times 36 times h. We can do our algebra in different ways and get the right answer, but I might cancel my pi's. I also might do 1/3 of 36, which is 12. So I really have 48 equals 12h. I'm going to divide both sides by 12. I'm going to find that my height is 4. Now that's not the answer to my problem. So step 2, now that I know my height is 4, let's go find that slant height. That's a right triangle. My height and my circular base is making a right angle. So I know that my hypotenuse has to be my c² by itself, and the other side is my perpendicular legs, in this case the 4 and the 6 in either order. So 16 plus 36 equals L². That's 52 equals my L². When we take the square root and put it in our calculator, we get approximately 7.24 L. And you know that would be centimeters. It's a length, so it's just plain old centimeters. It's not an area, it's not a volume, it's just my slant height, so it's just going to be a label of centimeters. The next problem, I believe that's different, is 13. So let's talk about 13. So 13, looks to me like this is a triangular prism. So there's a triangular prism on the bottom. I'm going to have to find the area of. And I'm going to add to it this triangular pyramid that is on top. So looks like I know all my measurements because I'm going to steal this from up above. So I know my triangle is 9 by 12, and I want to make sure I don't use the 15 because that is not my triangle base or height. That is my hypotenuse. I want to make sure I don't use it. So it looks like the volume of my prism is pretty straightforward. It's big B times H, where my big B is a triangle, so that's 1/2 my triangle's base times my triangle's height, times the height of the whole prism there. So the volume of that guy looks like it's 1/2 times that 9 times that 12, and this is the height of my prism. It's 10. So my volume there would be my 9 times 12 times my 10 times then 0.5, and I believe if you do that correctly on your calculator, you should get 540 feet cubed. That's the volume of my prism. So now let's talk this pyramid on top. I have a triangular base. I know my edges. That's nice. I don't need my Pythagorean theorem. But I'm missing this height, if you will, this perpendicular height from the top. I do know the height of the entire object is 24. And I know the height of my bottom part is 10. So I could say that this is my 24 total minus 10, or 14 feet tall. So now I'm ready to do my pyramid. My volume of my pyramid is 1/3 big B times H. My big B again is a triangle, so that's 1/2 the triangle's base times the triangle's height times the height of my whole pyramid. So when I put in my values, that's 1/2 times the 9 times the 12 times the 14. This time when I put my 1/2 times 9 times 12 times 14 divide by 3, I should get 252 feet cubed for my pyramid. I'm going to add them together to get a total volume of 792 feet cubed for this whole shape that we have there. So I believe neither one of the polygon volumes are on the worksheet. So let's take a look at number 14. Number 14 is a pentagonal prism, and I don't know the area of my pentagonal base. I know that my side length of my pentagon's 11, and I know the height of my whole prism is 4. So first of all, you guys, I need to find the area of this base. because I know that my volume is going to be big B times H. So I need to find that big B. So I don't know this apothem here, but I know I can use my trig to find it. This distance is 5.5, but I need to figure out this angle. As a reminder, a pentagon would be made up of 5 triangles. So I do my 360 divided by 5, which is 72. But this angle is half of that 72. So I get 36. So this is a trig problem where my 5.5 is my side opposite, my apothem is my side adjacent, so I'm going to do tangent, and tangent of 36 is opposite over adjacent. Let's multiply that variable up to the other side. Let's divide that tangent 36 away, and when I do that math on my calculator, one of the ways you can write your answer is 7.57. So now I'm ready to do my area of that pentagonal base. The area of my pentagonal base, which is my big B in my volume formula, is 1/2 the apothem times the perimeter. So that's 1/2 that 7.57 I found, times my perimeter. There's 5 sides and they're all 11, so then that's 55. So when I put all that into my calculator, I get around 208.175, what is this, yards squared. So going back to my volume, I'm going to take that base area. You don't need to use so many decimal points. You could use 0.1, you could use 0.2, you could use 1.17, sorry, 0.18. We've got lots of different answers we can get. So keep in mind, my answer may not match yours depending on how you decided around that. And it looks like when I multiply those, I should get around 832, sorry about that badly written 832.7 yards cubed, because this is volume. I did yards squared times yards and got yards cubed. So number 15 has 2 popular errors for us. So this is a great one to look at. First of all, let me figure out what this is. 1, 2, 3, 4, 5, 6. It looks like this is a hexagonal pyramid. And if I go look at my formula sheet, the volume is 1/3 the base area times the height. So first of all, I need to find that base area. That's the area of my base, my big B. And I'm given the apothem. What I don't know is this side length. I can't figure out my perimeter. So I'm going to sketch in this triangle, because when I do this triangle, I can use the fact my apothem is 6.1 to help me to find this little edge here. What I need, and this is tiny, let me go get a different color to kind of keep things straight. What I need is this little baby angle here. So again, I'm thinking about this being a hexagon. It can be divided into 6 triangles, which makes each triangle 60. And when I split that 60 in half, it makes that little angle, that little blue angle, 30. It's kind of hard to fit the 30 into that picture. So this blue angle is 30 that I have right here. So to find x, this is my side opposite, this is my side adjacent. I'm going to do tangent of that 30-degree angle equals my opposite over my adjacent. I'm going to multiply that 6.1 over. And it looks like when I multiply those, I get approximately 3.52. So this is where my first error can come in. Sometimes students take that 3.52 and they start working with it. But remember, that's just this little section. It's not the whole side. So let's take that 3.52, let's multiply it by 2. And when I do that, I get 7.04. My entire side of this hexagon is 7.04. that's going to help me find my perimeter, because I know the area of this hexagonal base, which is my big B in my volume formula, is 1/2 the apothem, which is 6.1, times the perimeter. So 7.04 times 6 is going to give me 42.24. I hope that's not being cut off of my video's edge. It's 1/2 times 6.1 times that 42.24, and my base area is 128.832 centimeters squared. Of course, you can round that differently. Of course. I'm just matching what I wrote on the answer key. So now I'm ready for the volume. This is the second error. Sometimes kids are doing so much math, they forget the 1/3, because this is a pyramid, not a prism. So don't forget that 1/3 times my base area of 128.832. Of course, you can round different, times that height of 12. Personally, I would do the 128.832 times 12, then divide by 3, and I believe we get 515.33 centimeters cubed. So the last problem is also slightly different from the original video. In the last problem, we're talking about a cone-shaped container orientated with its circular base on top. So something like, make it so I can write on it. Something like an upside down cone is what I'm looking at, okay? And it says its apex is at the bottom. That's this guy down here. It has a radius of 12, okay. It has a height of 8. Oh, nice, they gave me 2 good useful measurements. The cone starts to fill with water. Oh, I should have used blue for the water, but I'll use red. Starts to fill with water. What fraction of the volume of the cone is filled when the water is a height of 2? So I have water down here, and my water is a height of 2. And I'd like to find out what fraction of the volume of the cone is filled with water when it's at that height of 2. So I want to find the volume of the water divided by the volume of the cone. That will equal the fraction of the cone that's filled with the water. Like, is it half the cone? Is it 1/3 the cone? Is it 1/4 the cone? Is it 1/12 the cone? Like, what portion of the cone is filled with this water? Well, the volume of the cone is really easy. The volume of the cone is simple because it's from my formula sheet. What is that? 1/3 my pi times my radius squared times my height. And since I have all my measurements, that's 12 squared times 8. So I'm going to do 144 times 8, divide by 3, and I can get 384 pi inches cubed. So that's my cone. The problem with the volume of the water is I know the height is 2, but I don't know this radius. I don't know the radius. So I'm going to think about this as a miniature right triangle right here, where my height is 2 and my radius is r. So I need to find that radius. You know, I'm going to go all the way back to Unit 3 for a minute. Unit 3, when I did similar triangles, because I'm noticing that I have a blue triangle that's got a radius of 12 and a height of 8. It's a right triangle. And I have a red triangle that's got a height of 2 and a radius I don't know. And both of these triangles share the same bottom angle. And they both have a right angle. So these two triangles would be similar. Let me get a different color here. Both these triangles would be similar by the angle similarity theorem. So I could write a proportion, and I could solve that proportion. I could write it several different ways, but I'm going to write, let's say, 12 over 8. My radius over my height equals my r over 2. I'm going to cross multiply and get 24 equals 8r, divide by 8 and get 3 equals my radius. So now that I know that, I can find the volume of my water. Its volume equals 1/3 pi r squared h. So volume equals 1/3 pi times that 3 squared times that 2. Don't forget to square that 3. It's really a 9. So you have 9 times 2 divided by 3, or 6 pi inches cubed for the water. So the volume of the water is 6 pi inches cubed. The volume of the cone is 384 pi inches cubed, sorry. So it looks like my pi's are canceling, and 6 over 384 reduces to 1/64th of the cone is filled with water. Or, of course, you could use the decimal. What is 1 divided by 64? 1 divided by 64 is 0.015625. Of course, round wherever you want to round, of the cone is filled with water. Thank you so much for watching the video, and I hope something about it was helpful to you, and I will see you in class.